So this is an object, and it has a 2 kilogram mass, okay? And it is hanging from the ceiling. It's a disco ball, exactly. And if we wanted to figure out the tension in the rope, the string, the chain that's holding it, you would need to know what planet this was on. Why? Yeah. It's going to be lighter on the moon, heavier on Mars, a little heavier on Mars, not much, a lot heavier on Jupiter, okay? Very heavy on Uranus. That is the right way to pronounce it. And like the faint of heart say Uranus, which, how is that better?
It sounds different than saying Uranus.
Yes, it is, but I know. There's, by the way, this is a big astronomy like.
Other planets in the solar system, Uranus. We come to look at its dense atmosphere.
I remember we did Planet Project, and the group that had your kids made so many jokes.
And they're not even jokes. It's like.
Anything you say just sounds wrong.
Right. Did you know that Uranus is 12 times the size of the Earth? Did you know that Uranus is a gas giant?
What are you doing? Why would you name it this?
It's just, that's the way, it's the right, all right, let's get back to this. I don't know. Scientists with a sense of humor, I guess. Yeah, well, that's just going to have to be. So what's the tension in the rope? The tension in the rope is, was this the hour when Bloom came in too?
Yeah.
It's good that was yesterday. Yeah. So is the tension in the rope dependent upon the planet? Yes. Because the weight is dependent upon gravity. Now the mass will remain 2 kilograms. And here's the relationship. The weight of an object is equal to an object's mass times the gravitational pull, acceleration due to gravity on that planet. So on the Earth, it's 9.8. On the Moon, it's 1.6, and so on. Okay?
How do you find our mass? Never mind.
A little bit, yeah. So on the Earth, there are actually 2 systems that are used. The metric system is used more, but in metric units, weight is in newtons. Yes, indeed, named after Isaac. Mass is in kilograms, so there's our 2.0 kilograms. And what's the Earth's gravity in the metric system? 9.8. Yeah, 9.8 meters per second squared. So a newton is actually a kilogram meter per second squared. It's just an abbreviation. And so in this particular problem, our 2 kilogram mass will weigh 19.6 newtons. Okay? So in a free body diagram, you draw all of the forces that affect the object. So the weight of this is 19.6 newtons, and that means the tension will also have to equal 19.6. If the rope tension were greater than 19.6, what would happen? If the tension in the rope, which is holding this up, is greater than 19.6, it won't break. It'll, yeah, that's right, it'll float up. Good. If the rope can't support, like it has a tensile strength less than 19.6, then what'll happen? It'll snap and it'll fall down. Right. So this is a system in equilibrium, and that's what it is in the metric system. Now, in the English system, we use slightly different units. Who is comfortable disclosing their weight?
127.5.
That's awkward. I weigh
I was just thinking that myself. Andrew, how much do you weigh? Andy? 155. All right. So Andrew has a mass of 4.8 slugs.
Slugs!
Wait, slugs is an actual unit?
Slugs is an actual unit.
Pounds.
Yep. So 4.8 slugs. Gravity in the English, this is an English system unit. It was the weight, it was based on the weight of the King's Standard Cannonball.
That's cool.
Which is, that kind of makes sense that they called it a slug, right?
Yes.
Yep. And it weighed 32 pounds.
That's a big cannonball.
Guess what acceleration due to gravity is on the Earth in feet per second squared? It's close. 32-ish. It's 32.2, but dang, you were very, very close, Stephen. Nice job. So, 4.8 times 32 is Andrew's weight.
What?
Yeah, I just, did that on the calculator. Okay, you caught me. Yeah, so he has a mass of 4.8 slugs. When you multiply that by the Earth's gravity, that's where pounds comes from. That's where it's from where it is derived. Okay? All right. So, this is a very simple static equilibrium problem. It's sitting still. The tension in the rope is equal to the weight of the object. Alyssa, did you have a question, darling? Say it again? Yeah. Yes, that is correct. A Newton is an abbreviated unit, and it is a kilogram meter per second squared. Chris? Yeah. So yes, you're always, in metric systems, newtons and kilograms are matching units. All right. Let's make this a tiny bit more complicated. So now let's have our weight, our 2 kilogram weight, 2 kilogram mass, which weighs 19.6 newtons. Got it? Okay. Now let's,
Wait, can you explain that again? 2 kilogram mass.
2 kilogram mass weighs 19.6 newtons. I just multiplied that by 9.8 to get the weight. Okay? It's just a quick conversion. Now let's have a rope pulling it to the left, and we'll make that 21 newtons to the left. Okay? Point with your physics pointy finger in the direction, if we tie another rope to this, to hold it in equilibrium, to keep it from either going up, down, left, right, on an angle. Which way are you going to have to pull? It's like a little tug of war. Well done. And the question is, can you figure that out? Can you solve for that force?
Yeah, like vectors.
It is like vectors, and here's the rules. You ready? Super easy. Ups equals downs. This is for equilibrium. Yep. Thank you. And left equals right. Okay? So now I'm going to sort of fill out the rest of the triangle wherein F is the hypotenuse. So what would the horizontal component of this hypotenuse be in order to satisfy these conditions of equilibrium? 21. Good. And what would the vertical component of this triangle be in order to satisfy these conditions? Yay! Can you find F? You already did it? Seriously? He's cheating! You used Pythagorean theorem, that's correct. Nice. Rounding to 2 sig figs, you get, Stephen was right, 29. Tank?
You call him. Yeah.
Every day.
You think?
Every day.
Is that a good thing?
Yeah.
Okay. Please don't refer to me as a tank, however. All right. I may take offense at that. So 29 newtons is the resultant force. So that's it for equilibrium. Ups equals downs, left equals right. Easy peasy?
Yeah.
You want to see a problem like this on the test, don't you? Okay. Could you also find the angle at which you should pull it?
Yeah.
How would you do that?
Cosine, sine,
Yep, using any of the SOHCAHTOA things. What is the computer doing?